Hi everyone, this is Sejal, your tutor from Bright Mind Tutors. So, students, today we are going to learn one of the most important topics from the kinetics, that is how to find the rate equations, the order of any reaction, and the rate constant for a particular reaction. Through a past year paper question, we are going to discuss this. So, let's directly dive into the question. So, this is the question that we are having. So, it says the reaction between A and B. So, two of the reactant species we are having, that is your a and B, they are reacting and we are performing the reaction at a constant temperature. So these are the conditions that they have taken. Okay, the initial rate was measured for the different at the different initial concentrations of the A and B. So what basically is happening? The reaction is A plus B, they are combining and giving us the product B. Okay, so you can imagine that the rate constant for this particular reaction it is K. Okay, so now how do you write the rate expression according to the rate law expression? So rate is proportional to the various concentration terms, that is A and B, raised to the power of stoichiometries which are determined experimentally. So here you have this X and Y, they are determined experimentally. Okay, if you remove this proportionality constant, you take the rate constant K over here. Okay, A raised to the power of X and B raised to the power of Y. So what is X gonna determine? X is gonna give us the order, that is with respect to the A. Okay, and the Y, it is telling us that the order which we are having with respect to the B reactant. That is, if you vary the concentration of the A or the vary the concentration of the B, how is the overall order, how will overall rate of the reaction basically gonna change? This is what this order is gonna tell us. Okay, now they are determined experimentally as we have said. So now you can see the various experiments for this has been performed, right? Based upon that, now we have to solve the questions. So you can see four of the experiments data have been given, the concentration of the A and B and the rate expressions, rate values that they got, that values have been also given to us. Okay, so the very first question for this we are given that determine the order with respect to the A and B and showing your reasoning clearly. Okay, so we have to find the order with respect to the A and with respect to the B. That means this X and Y values we have to find it out. So what we do is we take the help of the ratio variation method in this. Ratio variation method. So now what is basically the ratio variation method? Now when we have more than two reactants or more than two reactant species when we are having in any chemical reaction, to find the order with respect to a particular reactant term. Suppose for the A I have to find it out, that is the X value we need to find it out. So what you do is you keep the concentration of the B to be the constant. So we will be choosing the experimental data in such a way that the B's concentration is kept to be the constant and A's concentration is varied. Okay, so you can see in the first two experiments, B's concentration has been shown as zero point 0.1 and zero point 0.1 only. That means it is kept to be the fixed, and the A's concentration it is varied, right? And correspondingly, the initial rate expressions values they have also given, that is also the varying with the change in the concentration of the A. So how you can write the rate expressions for the first two experiments? So we will be taking the help of taking first and the second experiment and the second experiment. From the first experiment, how you will be writing the rate value? Rate value is 2.4 into 10 to the power of minus of 3, which is equal to the rate constant K. Now A's concentration here we are having, which is zero point 0.1. It will be raised to the power of X. And B's concentration is also zero point 0.1. It will be raised to the power of Y of it. Right. Similarly, from the second experiment, the rate value is 4.8 into 10 to the power of minus of 3. This is gonna be equal to the rate constant K. Now, A's concentration we are having, which is 0.20 raised to the power of X, and B's concentration is again 0.1 raised to the power of Y of it. Take the this ratio of both of this. That means divide both of this. We will be getting 4.8 into 10 to the power of minus of 3 upon 2.4 into 10 to the power of minus of 3. This will be getting k values, they will get cancelled from both of this. We will be left as with 0.2 upon the 0.1 raised to the power of x of it. So you can see here we will be getting, on solving this ratio it comes out to be as 2 only. So 2 is equal to 2 raised to the power of x only. Now bases are same, powers can be equated. That means 1 is equal to the x. That means the order with respect to the a value we have got it as first order, right? So the first answer, that is, we were to determine the order with respect of the reaction with respect to the A. So this is the first order. Now with respect to the B also we have to find it out. So what we will be doing is we'll be choosing the experimental data in such a way that A's concentration we are keeping it to be the constant and B's concentration we are varying. Experiment second and third, if you observe, you can see here experiment second and the third. Here the A's concentration it is 0.20, which is the fixed one, and B's concentration it is varying. So these two data we'll be making use now. So let's find the order with respect to the B now. So using the second and the third, the rate equations that you will be getting, it is gonna be 4.8 into 10 to the power of minus of 3, which will be equal to the rate constant K into the 0.20 raised to the power of x of it, that was the concentration of the A, and 0.10 raised to the power of y, that was the B's concentration. And the other data we will be having, which is 4.32 into 10 to the power of minus of 2, which will be equal to the K into the 0.20 raised to the power of x into the 0.30 raised to the power of y of it. So take the ratios of both of this, we will be getting 4.32 into 10 to the power of minus of 2 upon 4.8 into 10 to the power of minus of 3, which is gonna be zero point 0.3 upon the zero point 0.1 raised to the power of y, right? So here you will be getting a value of 9 and this is gonna be 3 raised to the power of y. Now 9 can be written as 3 raised to the power of 2 and this is 3 raised to the power of y. So here the parts, the bases are the same, so parts can be equated. So that means the order with respect to the B we have got it as second. With respect to B, it is of the second order. So total it was a 4-marker question. So if you solve firstly the order with respect to the A, you find it, the complete changes that we are seeing here, that complete explanation with that if you give it, you'll be getting a 2 marks for this. Similarly, for the B, you solve it in this particular manner, you will be getting another 2 markers. Total 4 marker you will be getting this. Okay. Now next question we are having is this one. Write the rate equation for the reaction. So you can see the rate equation we wrote it, that it was rate is equal to the K into A raised to the power of x and B raised to the power of y of it, right? Now x and y values you have got it, just substitute that, you will be getting your final rate equation from here, right? So here the rate expression, it was equal to K into A raised to the power of x and the B raised to the power of y of it. R will be equal to K into A raised to the power of y and B raised to the power of 2. So this is gonna be the rate equation, right? So if you write this particular equation, you will be getting a 1 mark for this. Okay. Now the next discussion you are having, calculate the value of the rate constant K including its units. So two of the things, rate constant value and along with that its units, you have to also find it out. Now the rate equation we have obtained it, right? You can choose any of the given experimental data from here. You can choose any one of them. You will be taking the rate values from here. The initial concentrations corresponding to that particular rate expression only you have to choose it. I am taking the experiment number 1 and you will be finding the rate constant K value. So our rate value will be 2.4 into 10 to the power of minus of 3 and concentration values will be 0.1 and zero point 0.1. So let's solve this now. So we know this, that the rate equation we got it, rate was equal to K into the A into the B raised to the power of 2 of it, right? So rate value it is 2.4 into 10 to the power of minus of 3. This will be K into the A value, which is 0.1 raised to the power of 1 of it and the here 0.1 raised to the power of 2 of it. On solving this, the K value you will be getting, which is gonna be 2.4, right? Now if you just find the value of the rate constant K value, you will be getting only 1 mark for it, okay? But along with that you have to include its units also. How I'll be writing its units? So you see, what is basically the order? The sum of the power of the stoichiometries experimentally that you have obtained. Now here it is A to the power of 1 and B to the power of 2. That means this reaction it is of the third order, right? It is of the third order. The general rate constant units values you have, it is mole per decimeter cube or mole per liter also you can write it. It is 1 minus of the n and the second inverse, where n is the order of the reaction. Now here the n value we keep it as 3 and write the units of the rate constant. So it will become mole per decimeter cube raised to the power of 1 minus of 2, 1 minus of 3, sorry, per second, right? So it will become 2.4 mole raised to the power of 2, that is minus of 2 into the decimeter raised to the power of 6 per second. So this complete value, if you write it, you will be getting a 3 marks for this. Okay. Next, this question now. Calculate the initial rate in the experiment 4. So if you observe in the experiment 4, the initial concentration values have been given. The rate value we have to find it out, right? So concentration of A is 0.30 and B's concentration at is 0.20. So let's find the rate values now. So rate constant values we are also knowing and the concentration values we are also knowing. So rate value we can easily find it out now. So rate value was equal to K into the A raised into the b raised to the power of 2 of it, right? So k value we have found it as 2, a value we have got it, it was 0.20 or sorry 0.30 it is there, and b's concentration it is 0.20, the square of it. Just solve this, the value you will be getting 2.8 into 10 to the power of minus of 2. Make sure you write the units too to get the full marks for this. Units will be mole per decimeter cube per second. Okay, so this is gonna be your answer for this. Next, the temperature is increased. State and explain the effect on the value of the K. So how is the K value basically gonna change if you change the temperature, whether you increase it or you decrease it. Okay, so what we generally observe is as the value of the temperature it increases, the rate constant values it also increases. So we say that K value it increases as the temperature it increases. So this is what we write it. So if you write this particular statement, you will be getting a 1 mark for this. Okay, now you have to explain also why is this thing happening, that the value of the K with the change in temperature, the K value it is increasing. So it is because higher is the temperature, greater is the portion of the molecules, greater is the portion of the molecules, portion of the molecules having the energy greater than that of the activation energy. Activation energy is basically the minimum energy which the reactant molecules must possess so that they can get into the product. So with the increase in temperature, the number of the molecules which will be having the energy more than that of activation energy, that is gonna increase. So if you write this second statement, again you will be getting a 1 mark for this. Now one more statement, if you write it, now we have said that more number of molecules will be having the activation greater than that of the activation energies they will be possessing. So that what is gonna happen? So the reactions they occur due to the collision between the molecules. So all the more number of the frequent collisions, it is gonna be the successful collisions. That means they will be resulting into the product formation, right? So we can say that more frequent successful collisions we will be having. Successful collisions will be there when the K value is larger as the temperature it increases. As the temperature it increases, we can show this using the Arrhenius equation also, that rate constant K is A into e raised to the power of minus of the E upon the RT. You can see as the temperature it increases, the rate constant K value also increases. If you include all these 3 points, you will be getting a complete 3 marks for this. Okay, so this was all about this session. I hope this topic, that is how to find the rate equations, the rate constant and the order of the reaction for any particular reaction, it is clear to you. Thank you so much.